Who would have expected Beabadoobie to crash out? Okay, maybe you're watching this like years later, but I'm not gonna lie, just on Instagram Reel and Beabadoobie is crashing out on people. That trend where it's like singers who can't sing and singers who can sing, and they put the singer who can sing as like NBA YoungBoy or something. Why am I writing this down? I don't know. And they put like lasers shooting out of his eyes. Put like lasers shooting out of his eyes while he's singing. I don't know. And they say singers who can't sing. Why am I writing this down? Okay, let's just start. Whatever. All right, I'm gonna cover like planes. So let's see. A 2D plane. Let's just say plane, or a surface of a plane on a 3D space. So we're gonna show you how to like, I guess, represent it as a like a formula. You know what I'm saying? So like in a traditional Cartesian plane, you're gonna have a line, and there's multiple ways to represent that line. I know mx plus b. You know, slope intercept form, and there's like, what was it? Y minus y null is equal to mx minus x null. Right? This is point intercept form. Right? You can represent a one-dimensional line in a two-dimensional space, but you can also represent a two-dimensional space on a three-dimensional space. A two-dimensional plane on a three-dimensional space. So how can you do that? Well, let's actually go over to 3D Desmos and show you first what I'm talking about. So I'm going to cut to that part right now. So as you can see, we are in 3D Desmos right now. And like, this is what a plane is. So I just drew some random plane, okay? And as you scroll out, as you know, it's not actually the shape of a hexagon. Like if I just make another plane, like let's go ahead and make another plane. Let's like x equals like 0 or something. That's a line. Oops. X plus y plus z. Like this is just another plane here. But a plane is just a two-dimensional surface. And I'm just gonna keep scrolling out, right? It's just literally just a flat surface. If you look at it from the side, it's just a flat surface. So a plane is just a 2D surface inside a 3D space, right? Two-dimensional. Like, I don't know. There's only length and width here. If you don't understand dimensions, then that's fine. It's just understand that it's just a flat surface in a three-dimensional space. And you might be wondering, what in the world is this arrow here? Well, this arrow is actually if you look here, I guess you can kind of see the plane right here. It's perpendicular to the plane. And this is what we call a normal vector. So, I don't know if you've taken a physics class, but normal force is the force that acts perpendicular to a surface. So, right now, the plane is the surface, and currently, this normal force, or this normal vector, is pointing perpendicular to this surface. So I'll show you how to represent this plane as an equation using the normal vector and using some point on the plane. So two things you need: a point and a normal vector, and then you can make the equation for a plane in space. What I said before, you need let's put a bullet point here. You need a normal vector. So normal, nope, m here. Normal vector. Let's fix that t. Normal vector. You also need some point. So point on the plane. Any point. Point any on the plane. On plane. Doesn't matter which one it is. Just any point, given point. And a question's going to say something like, let's see, you have a normal vector of 2, 2, and 2. Let's make this very, very simple for you. 2, 2, 2. Okay? So this is the normal vector. It's pointing in the direction and magnitude of 2, 2, 2. The magnitude honestly doesn't matter the direction. What truly matters for the plane. Let's say that we have a point 1, 1, 1. Okay, yeah. Very easy numbers here. So the equation for a plane will be the components of the, here, let's actually make a formula first. Shit, like I hat, maybe? Shit, like I hat? Nah. I'm gonna search this up real quick. Okay, so The equation of a plane, this is just something easier to understand than what I was about to write with the I hats and shit. But it's basically just AX plus BX. No, not BX, plus BY plus CZ is equal to A times X null plus B times Y null plus C times Z null. And these nulls and these A, B, and C represent points on the normal vector. So this is normal vector. And these are the values A, B, C. And X null is any point on the plane. So these null points are representing the X nulls, and the Y nulls and the Z nulls are representing the components of the point on the plane. And this A, B, C is representing the vector values. So we just plug these in, honestly. So we just get 2x plus 2y plus c, not C, 2z is equal to 2, because A, grab them there, times 1 plus 2 times 1 plus 2 times 1. And let's change up the numbers so I guess you can get this better. But as you simplify everything, you get 2 times 1, 2 times 1, 2 times 1. Add together, you get 6. So this is the equation for the plane given by a normal vector 2, 2, 2 with a point at 1, 1, 1. That's actually, go ahead and try another one without using such confusing numbers like 2, 2, 2 and 1, 1, 1. Let's say that the normal vector is 6, -2, and 3. So this is the normal vector. We label the components A, B, and C. And let's say it has a point -3, 5, and 2. And these are X null points, Y null points, and Z null points. So let's redraw that null. So AX plus BX plus, no, not BX, plus CZ is equal to A times X null plus B times Y null plus C times Z null. So it honestly, it just has a pattern. This beginning part's super easy to remember. You might see this in a different form. I think it was like a X minus X null plus BY minus Y null or something along those lines. These are just the same thing, honestly. I like using this one because this one's easier to just remember and just easier to plug in all the values for. So let's go ahead and write down the equation for this plane given the normal vector 6, -2, and 3, and with a point on the plane -3, 5, and 2. So plug in A, which is 6, plus, it's actually minus because B is -2, 2y, C is 3. So we plug in C here. Is equal to A, so 6, times X null, which is -3, plus B, -2, times Y null, which is 5, plus C times Z null. Simplify everything, and then you get, let me do the math real quick. This is -18, negative 28 plus 6 is equal to -22. So this is the equation. This right here is the equation for this line. For not for this line. For the plane, given the normal vector or the vector that is perpendicular to the plane at points given these points on the graph. So if you plug in a different point, so let's say maybe you have a different point on the graph, on the the plane, right? Use a different point on this plane. If you graph the plane on 3D Desmos, it's going to be the exact same thing. As long as you just use a point on the same plane, it doesn't matter, okay? So you can have probably multiple different ways to represent this same plane. You honestly don't have to overthink it. Just stick with this form and go ahead and do that. Okay, let me actually, and I'm just going to erase this up here. Let me actually give you guys a couple problems that you can solve for this. So I'll give you the normal vector. Let's give you the normal vector like 6, -3, -4. So this is a normal vector. We'll give you a point on the plane, point P, at 0, 3, and -9. So go ahead and solve for the equation of the plane, given the normal vector 6, -3, and -4 with at point 0, 3, -9. So once you're all done, I am going to write this down. Okay, so we're starting off with ax, right? Ax plus by plus cz. Hopefully you remember this by now. If you don't, just look at it a couple more times. So the equation for this plane is just 6x, because 6 is the a value here. We pair it up with the first x. This is the b value, this is c value. So minus 3y minus 4z is equal to 0, 3, -9. We multiply each corresponding point, so it's literally just the x component times the y component times the z component. The z components of each, or the, I guess this could be like the k hat component, I don't know. The z components of each like normal vector and point multiply by each other. The y components multiply by each other. The x components multiply by each other. It's not that hard to remember. Let's undo all that. Okay. So 6 times 0 is just 0. -3 times 3, so -3 times 3, plus -4 times 9, which is just 4 times 9. This turns out to be 3y minus 3z is equal to 0 minus 9 plus 36. Simplify all that even further, and we get 27. So this is the equation for this plane. Hopefully you got that right. Just do one more problem. Okay. Let's say the normal vector is, let's do a bigger number, -10, -12, and 31. I don't know. And let's say a point on this is, let's call it point P. Point on this plane is -2, 4, 6. So go ahead and solve for the equation of this plane. So you're all done. I'm just going to plug in these numbers. So this is -10x minus 12y plus 31z. Why did that 3 cut off? 31z. -10 times -2 plus -12 times 4 plus 31 times 6. So where did I get the -10 from? I got it from this form here. Let's go write this down just one more time for you guys. It was a times x null plus b times y null plus c times z null. And this was x null, this is y null, and this is z null. A, B, and C. So once you have those values, all you have to do, plug it in. So -10 is A. We put that into A here. So we have -12, which is B. We plugged in -12. 31, which is C, plugged in C. And A is -10, so we put A back up here. X null is -2, so we put -2 here. B is -12, so we put B here, and so on and so forth. And I don't think I can even draw any more of the arrows. I'll try. This works. Okay, yeah. So I got C, 31 again, and Z null, the Z component of the point. It's not that bad. All you need are two things. Remember, normal vector and a point on the plane. I mean, like, I guess I could simplify this in case you guys did. I'll try to simplify it. See if we got the same answer. This is 20 minus 48 plus 186. So -10x minus 12y plus 31z. This damn pen is like so uncomfortable to hold. It's like hurting my finger. Okay, well, I'm just gonna watch for you after this, so it's fine. My finger will feel fine after that. -28 plus 186 is, I'm trying to do some mental math here, 158, I think. Hopefully I got that right. I don't know, just use a calculator. But up to this part, hold up. Up to this part should be right. So this is the answer I got. This is the equation of the plane in a three-dimensional space given by the normal vector and any point on the plane. Two things. I'll repeat this again. Repetition, get it in your head. You need a normal vector, which is the vector that is perpendicular to the surface. So vector is perpendicular to the plane. Hopefully you can read my handwriting. And the point is, you need two things, any point on the plane. So remember, you need two things, a normal vector, any point on the plane. And then you can use this format here, or the format that your teacher or professor is using, and there it is. The formula for a plane in three-dimensional space. If you have any questions, put it down in the comment section.